This short presentation introduces you to mass balance interpolations of the glaciological method. We're going to explain you how to get to glacier-wide mass balance from point measurements.
The first important step is to check your data for possible errors. Do we have suspicious data? Is the data in meter water equivalent, or do we still need to convert it? Has the right coordinate system been used, and also, which time system has been used? If all those points are checked, the real calculations can begin. But how can we go from only point measurements to a glacier-wide mass balance? The solution is interpolation.
The first interpolation methods that we have a look at are semi-automatic approaches based on GIS. Here we can see that 3 different interpolation methods result in 3 completely different glacier-wide mass balances, and thus also in significantly different ELAs. Uncertainties in using GIS software for interpolations are that it neglects glacier mass balance distribution processes, plus, in most cases, the insufficient data coverage results in bad interpolations. We can see this quite nicely if we compare the actual ELA for Vinderen Glacier with the interpolated ELA through the thin plate splines methods. Ultimately, this shows that GIS does not work in most cases and does only work well if a high data coverage is available.
A different method to calculate glacier-wide mass balance is the contour line method. It is the oldest method used for mass balance calculations, and it is a manual method. Integration of expert knowledge helps improving the accuracy of the mass balance calculations. For Vinderen glaciers, this is how the contour line method can look like. However, also this method is accompanied by uncertainties. With less point measurements, the accuracy decreases. Furthermore, results generated through this method are subjective and are strongly influenced by the knowledge of the interpreter.
Finally, we'll have a look at the third method, the profile method. It is another semi-automatic approach that compares mass balance with elevation. It provides a good overview of the total mass balance and can be combined with other information, like done in the example with the area distribution. This method also has its uncertainties. Namely, it does not respect the glacier's properties, abnormalities, and mass balance distribution processes. If data coverage is low, the result is not accurate and the mass balance profile at the top must be corrected by inverting the curve.
These were 3 methods of interpolating mass balance data. Thank you for your attention.